Hello guys, today we're going to be doing the Unit 2 review, which is over solving all types of equations. So let's get started at the beginning. The first type of equation that we solved was a linear equation. So I have 3x plus 4 parentheses 1 minus 2x equals 4 parentheses x plus 5 then plus 2. The first thing you always do when you're solving is get rid of parentheses, so we are going to distribute what's in front. So the left side is going to turn into 3x plus 4 minus 8x equals, and then on the right side, we'll distribute, which gives us 4x plus 20 plus 2. Next, we combine like terms. So on the left, we can combine the ones with the x's. That gives me negative 5x, and I still have my plus 4, equals, on this side I can combine my constants, so that becomes 4x plus 22. Then I want to get my x's on the same side, so I'm going to subtract 4x so that it can cancel out, and do it to the other side. So that gives me negative 9x plus 4 equals 22. Now our job is to get that x by itself, so subtract 4 so it can cancel. Negative 9x equals 18. Divide by negative 9, and I get that x equals negative 2. Okay, the next type of equation that we solved was an absolute value. When solving absolute values, you're going to get two answers because you need to account for if inside the absolute value was positive or if it was negative. So first step is to get the absolute value by itself. I'm going to do that by subtracting 3 from both sides, so that cancels. And I'm left with 2. Absolute value of 7 minus 2x equals 6. Then I still have that 2 out front, so I'm going to divide by 2. And now I have absolute value of 7 minus 2x equals 3. So now that the absolute value is by itself, I can set up my two equations. So one of them, all we're going to do is take off the absolute value lines and have 7 minus 2x equals 3. That accounts for the positive version. The other one, I'm going to still have the same equation, so 7 minus 2x, but to make it negative, I'm going to have it equal negative 3. Then we solve these two equations. So I would subtract 7 from both sides. Negative 2 equals negative 4. Divide by negative 2. So x equals positive 2. That's one of my answers. Then same thing with the other equation. Subtract 7. Negative 2x equals negative 10. Divide by negative 2. And x equals 5. So when I write my answer, I would write it as a set. So x equals the set 2, 5. Okay, next up, we did inequalities. So I'm not going to do a linear inequality because it's the same way, but I am going to show you a absolute value inequality. So everything's going to stay the same as far as solving is concerned. The only thing you really need to worry about is if you divide by a negative, you need to flip that symbol. So let's start by getting this getting that absolute value on its own. So in order to do that, I'm going to subtract 3 from both sides, which leaves me with negative 2. Absolute value of 10 plus 4x is greater than negative 28. Then I'm going to divide by that negative 2. So see here, since I'm dividing by a negative, that inequality symbol is going to flip. So it's going to be less than 14. Now that that absolute value is by itself, I'm going to set up my two equations. So I'm going to do that to the side again. So for the first one, we're going to leave it the same. We're just going to take off those absolute value bars. So 10 plus 4x is less than 14. For my other equation, I'll have 10 plus 4x, but we flip the symbol so it'd be greater than, and we make it negative, so minus 14. Now let's solve these two inequalities. So I would start by subtracting 10. 4x is less than 4. Divide by 4, so x is less than 1. That's going to be one part of my answer. Now let's do the same thing for the other equation. Subtract 10 from both sides. 4x is greater than negative 28. Divide by 4. So x is greater than negative 7. That's the other part of my equation. Or I'm sorry, inequality. So when I write my answer, I'm going to combine these two things. So you always do it as an inequality notation, but it's going to be a compound inequality since there's two of them. So we go smallest to biggest. So between our two answers, negative 7 is the one that's smaller. So we're going to start by writing that first. And then have my x. But see how I had to switch the order here? Like for my answer, it was letter and then number. But when I'm writing it here, I'm doing number then letter. So that means that this symbol here is going to flip and go like this. But now I need a way to include my other inequality. Well, here I had x is less than 1. So when I'm here, I already have my x. So I just need to finish it off, is less than 1. So that is how the answer will look, as that compound inequality. Okay. Next, we solved radical equations. Radical equations are pretty similar to absolute value in that you need to isolate the radical before you do any solving. So let's start by adding 3 to both sides, which gives me 2 square root of 5x plus 1 equals 8. Then I'm going to divide by 2. So then I get square root of 5x plus 1 equals 4. Okay, but I want to get rid of that radical. So the opposite of square root is to square, so that's what I'm going to do. But what you do to one side, you have to do to the other side. So that leaves me with 5x plus 1 equals, well, 4 squared is 16. So now it's just a linear, and we're going to solve. So subtract 1. 5x equals 15. Sorry, I ran out of space, so I'm going to do this to the side. I'm right here. 5x equals 15. Okay, and then the last step is to divide by 5. So x equals 3. Okay, so I want to do another radical equation, but this time there's square roots on both sides of the equal sign. So that's okay. As long as they're isolated, we can still solve this. But the first thing we want to do is get rid of those square roots. So opposite of square root is to square. And what you do to one side of the equal sign, you have to do to the other. So once I square both sides, I'm just left with 3x minus 7 equals 2x plus 2. No more square roots. Now I want to get my variable to one side, so I'm going to subtract 2x from both sides. And that leaves me with 1x minus 7 equals 2. Add 7 to both sides. So then I'm left with x equals 9. So notice I took off the 1 right here, because anytime there's a 1 in front of a variable, you don't really need to write it anymore. So that just saved me some time on my solution. Okay, the next type that we did was a rational equation. Rational equations are set up like giant fractions. So if I wanted to get rid of those fractions so I wouldn't have to deal with it anymore, I need to multiply the entire thing by the lowest common denominator. Lowest common denominator. So start by looking at all the denominators of each of these radical expressions. I have 2x squared, x, and 2x. So let's start with just the coefficients in front. This one has 2. This one doesn't have anything in front, so it's an invisible 1. And this one has 2. So the least common multiple of those denominators would be 2. Then look at the variable. I have x squared, x, and then x. So out of those three, the biggest one is that x squared, so that's going to be part of my lowest common denominator. So now that I know what my LCD is, I'm going to multiply the entire equation by that. So that would be 2x squared times 2 over 2x squared equals 2x squared times 1 over x minus 2x squared times 1 over 2x. So once I do my multiplying, things are going to cancel out and I won't get my fractions anymore. So in that very first one, 2 cancels with 2, x squared cancels with x squared, and all I'm left with is that 2 on the top. So that first term, it's just 2 equals. Then let's look at the next one. That x squared on the top, you have to remember that x squared is kind of like saying x times x. So I can cancel out one of them. So remember, we replaced that. And that's really all I can cancel, so I'm still left with 2x and 1. So when we multiply everything together, 2 times x times 1, we get 2x. Then I'm going to bring down this minus sign. And then for that last one, same thing. X squared is the same thing as x times x. So when I'm canceling, I can cancel out the 2, and I can cancel out one of those x's. So all I'm left with is x times 1, which just gives me x. Now we're going to solve this resulting equation. So first let's combine like terms. I have 2 equals, and then for those two, I have 2x minus x. So that would just be 1x. So I'm not going to write the 1, I'm just going to write x. And it turns out that's kind of already solved. The variable's by itself. It's just backwards than what we're used to seeing. So I'll just rewrite it. X equals 2. Okay, and let me practice with another rational equation. So this one's going to be a little bit longer, but it's still the same process. So first thing is to find out what is the lowest common denominator here. So let's look at our coefficients of the denominators. I have 3, 6, and 6. So our least common multiple there would be the 6. Now look at the variables. I have n to the second power, n to the second power, n to the third power. So we always take the biggest one, so n to the third power. So that is my least common denominator. I'm going to multiply the entire equation by that. So 6n to the third times 4 over 3n squared minus, 6n to the third times 5 over 6n squared equals 6n to the third times n minus 4 over 6n cubed. So now we're going to simplify as much as we can. So on that first term, there's a little bit of rewriting that I need to do because, let me zoom in a little. 6 can just be rewritten as 2 times 3. And then that n to the third power can be rewritten as n times n times n. The reason why this matters is because when I'm doing my canceling out, I have this 3 on the denominator and 3 in the numerator, so those cancel. Then n squared cancels out 2 of those n's, 1, 2. So what am I left with? I'm left with this 2, this n, and this 4. So for this term, we multiply what's left, and I'm left with 8n. I'm going to bring down this minus sign and do the same thing for the next one. So with here, you have to remember that n is the same thing as n times n times n. So when you're canceling out, cancel out the 6's, and then this n squared is going to cancel out 2 of these n's. So I'm left with n and 5. So that term becomes 5n equals, and for this side, 6 cancels with 6, n to the third power cancels with n to the third power. So all that's left is n minus 4. So we're going to solve this resulting equation. 8 minus 5 gives me 3n equals n minus 4. I want my n's to be on one side, so I'm going to subtract it here. And I'm left with 2n equals negative 4. Divide by 2. So n equals negative 2. Okay, next is the complex number. I didn't put any adding or subtracting because that was too easy for the review. But let's do some multiplying so that we can remember how to do this. And I'm going to multiply by using FOIL. So first, 2 times 5 is 10. Last, 2 times negative 2i is negative 4i. Inside, so 3i times 5 is 15i. And then 3i times negative 2i gives me negative 6i squared. So the rule is anytime that you see I squared, so in that last one, you replace it with a negative 1. So when I do that, this becomes negative 6 times negative 1 is positive 6. Now we can combine our like terms. So in complex numbers, we always have the real part first. So 10 plus 6 is 16. And then we do the imaginary. So negative 4 plus 15 gives me plus 11i. Okay, now we're going to solve a quadratic equation. This one is factorable. So let's start with our factoring by doing our little t-chart to the side. And with this t-chart, on this side is AC and on this side is B. So remember, it goes in order. This is A and this is C. So when I multiply them, AC, that gives me negative 6. So factors of negative 6 include negative 1 times 6, negative 2 times 3, and then positive 1 and negative 6, positive 2 and negative 3. So we have 4 different options, and the way we pick which one we're going to use is by looking at our B, negative 5. We need the one that adds up to negative 5. So that first one gives me positive 5, so that's not exactly what I wanted. This next one gives me positive 1, again, not what I wanted. This next one gives me negative 5, so those are the ones we're going to use. X positive 1, x minus 6, and it still equals 0. Okay, so the problem here is, where did our leading coefficient go? If I were to remultiply these, there wouldn't be a 2. So the way we're going to fix that is divide both the numbers by 2. In that first factor, 1/2 is as simple as it can be already. So what we're going to do is we're going to get the bottom and put it up. So that gives me 2x plus 1. On the next one, 6 over 2, that can be simplified to just 3. So when I rewrite that factor, that's x minus 3 equals 0. And now to solve my quadratic equation, I'm going to set each factor equal to 0 and solve. So I would subtract 1. That's 2x equals negative 1. Divide by 2. So x equals negative 1/2. That's one of my answers. Then for the other one, add 3 to both sides. So x equals positive 3. That's my other answer. Again, anytime you have more than one answer, it's going to be written as a set. So x equals the set negative 1/2, comma 3. Okay, and one last example for you. How do you solve a quadratic when it's not factorable? So you are going to have to actually check to see if it's factorable first. And then if it's not, you're going to use the quadratic formula. So just label your A, B, and C. So A is 2, B is 6, and C is 9. So our quadratic formula starts off with x equals negative b, but instead of b, I'm going to put 6, plus or minus the square root of b squared, so 6 squared minus 4ac, so 4 times 2 times 9, all over 2a, so 2 times 2. So now that it's set up, I want to simplify as much as I can. So I have negative 6. I'm going to take off those parentheses, plus or minus square root. 6 squared is 36. And then for this part, I have negative 4 times 2 is negative 8. And then negative 8 times 9 would give me negative 72. So minus 72. All over 2 times 2 is 4. So inside that radical, I have 36 minus 72. That gives me negative 36 over 4 still. Anytime you have a negative inside the square root, you're going to replace it with an I. So this will be positive square root of 36, I over 4. So now take a look at that radical that's there. Square root of 36. Can you simplify that? So I'm going to kind of do this off to the side so I don't waste any space. But here's my 36. What can I split it up into? Well, 2 times 18. 18 is 2 times 9. And 9 is 3 times 3. So I have a pair of 3's and a pair of 2's. So 2 times 3 gives me 6. So you could have saved yourself time if you just knew that 36 is a perfect square and the square root of it is 6. But if you didn't remember that, you could always do this little tree. So I can rewrite this as negative 6 plus or minus 6i, because it's not a square root anymore, over 4. Now this is a complex number technically. We just got to separate it into our two separate fractions. So what I mean by that is just this part here, is its own fraction. So I'm going to start by writing my answer, x equals negative 3 over 2. I went ahead and simplified it. Then plus or minus. Then this part is its own fraction. And same thing, I have 6 over 4, which I know can simplify to 3 over 2. Oh. But it still has an I with it. That's my answer. So you might see it like this, where it's still together, or you might see it where they separate it. So negative 3 over 2 minus 3 over 2i, and then negative 3 over 2 plus 3 over 2i. Either way is correct. Okay guys, that's the entire review for all the equations that we solved. I included a you-do side with more practice questions for you to do, and I even included the answer for each one. That way, when you're working them out, you could just check to see that you got the correct answer. Okay guys, and if you have any questions, just please let me know. Bye.